right, guys. I'm recording the homework review as well as going over the new stuff. Hold on a sec. I don't have the notes up. Go check here. Hold on, my computer's acting a little sluggish.
It's a classic.
All right, okay, guys, we're getting started. So here's the homework 44, or 7.4 homework. So it's just 5 problems, and it's pretty consistent. Like, hey, find me the real zeros. Turn the multiplicity beat 0. Give me the maximum number of exponents, which is just 1 minus a degree. Test for symmetry, I don't care. Don't do D. E, determine the graph's end behavior using the limit notation, like, or as x approaches negative infinity, what f of x does, as x approaches positive, what does fx do? Well, Alexander, you're here. Welcome back. Yeah, you did the test finally. Good, congratulations. Good, all right. And then sketch the graph. And when I sketch the graph, I usually like to do a sign chart to see whether the graph should be above or below the x-axis at various places. But of course, you have bounces and crosses at different x-intercepts. Or you can make a table, that helps. So you can see for number 1, factor as much as you can, get the x-intercepts. They actually did the symmetry here, which actually is an even symmetry, I suppose. So fine, but honestly, I don't care. You give a cross at -4 and 4, but a bounce at 0. Maximum returns is 3. End behavior is that, and there's a graph. I guess the symmetry can help just to make sure you got the graph right, but most of the time they're not going to be symmetric, so I wouldn't worry about it. Here, factor out -x squared. Zeros are 0 and 3. Multiplicity of 2, multiplicity of 1. Max turn, symmetry, blah, blah, blah. You got that. Pretty simple. 3, it's right factor for you. There's going to be no symmetry here. So don't waste time investigating it. Anyhow, you have a cross at -2, a bounce at 0, cross at 1 because of the multiplicities. And maximum turns is 5, but doesn't show 5 turns. And there's your end behavior there. 4, great factor for you. Again, don't waste time testing the symmetry because I don't think it doesn't, no symmetry either. Cross, bounce, cross at -2, 1, and 2 respectively. Maximum turns is 3. And you have that. And then lastly for 5, again, no symmetry. That's why I think it's just dumb we're asking that. It's a great factor for you. I'm not sure why it was fully expanded. I guess for the symmetry part, but again, just don't worry about it. Degree 6, multiplicity is going to be -4 is multiplicity of 2, 0 is multiplicity of 1, 1 is multiplicity of 3, so it's bounce, cross, cross at -4 and 0, 1 respectively. Maximum turns is 5, 1, 2, but only shows 3 turns, but maximum turns could be 5. And that's that. Okay, so we're good? All right, I know, very dry, boring homework, but it is what it is. All right, here's what we're going to do. We're going to focus on polynomial division. It's very short, only 2 pages. And the homework's also 2 pages, so it's a very short homework. I imagine most kids can get done and can just relax. And it's been a long day. You know, we've had 4 classes. I mean, I taught all my classes today, so I'm pretty tired myself. The answer key's right there, which should be already posted to Schoology. Let me just double check Schoology really fast. See Precalculus. Chapter 7. Yeah, answer key's right there. The baseball players, what time are you guys leaving? Okay, so you'll be able to see the notes. And what's the other sport? What time are you guys leaving? Oh, I thought it was 2 people. Wait, 4 people have early dismissal. Who else plays lacrosse? Oh, 2:30. Oh, that's what it was. Got over tennis. Yeah, you're not gonna play tennis, right? Yeah, you're not playing this. That's not happening. But even baseball, are you guys gonna still play?
We're on a turn 2.
Huh?
This is the amount that gets all muddy.
Yeah, it's true. Yeah.
He's an American. He waits until like last second if he's gonna cancel.
Oh, really? Wow. Okay.
Like,
all right.
We won't find out probably until 3:30.
Got it. Got it. Okay. It's no rain out. All right, guys, let's get started with the notes. Here we go. So let's talk about long division. Some of you guys probably did, I'm guessing, 4th grade or 5th grade. I don't know when the long division is really taught. I don't remember. But we're going to have to talk about polynomial division eventually. Mainly because this will play a role when you do take calculus next year. Sometimes you have to use this technique for one of these things it's called integration or like antiderivatives. You have to use the technique of long division sometimes to do this. So I'm going to show you how to do long division as well as synthetic. Synthetic actually I think is a better technique if you can use synthetic division. I'd strongly recommend that if you could. So starting with this one here. Remember long division. You guys remember how this works? How do you get this kick-started? What do you guys do? Yeah, put a one. Well, figure out how many times 13 goes into 16, which is once. Subtract. Oh, third grade. There we go. And how many times does 13 go to 35? Twice, right? So you get 26. The remainder is 9. So it's 12 and 9/13 if you want to write it like that. If you wanted to. Or 12 plus 9/13. That works too.
What's that between the 2 and the 9?
Or remainder. Remainder. So the remainder of 9. If you try it again, I think this one comes out clean. That goes in twice. So 0 times. Sorry, I gotta bring the 5 down. That's 51. What's the purpose? When you get to calculus, it'll be more of a purpose. It doesn't make sense now, I know. But you will have to use the technique calculus, trust me. And remainder is 0, so it's 202. So that comes out nice and clean. So what we're doing right now is I'm just going to show you the process of long division because we're going to apply that to polynomials. It's a little more messy with polynomials, but it's still the same thing in the sense that you have something on the outside. How many times does 13 go into 16? Something like that. You multiply, you subtract, and you kind of rinse and repeat, right? And there's a simpler division problem off to the top right corner. So, and for dividing, make sure you put the terms in descending order. And if any terms are missing as you go in descending order, you have to put 0 as a placeholder. So let's look at example 3. These are not fun, but you know we'll get through it. Good thing the notes are not terribly long today. Need more space. Here we go. What's your leading term for example 3? Of the top. 8x5, right? And is there an x4 term? So you got to put 0 as a placeholder. Is there an x cubed term? No, 0 as a placeholder. Is there an x squared term? You bet. Is there an x term? Yes. And then 2. Ugh. All right, let's get moving here. Here's what you do. It's the same thing as before. What do you multiply to x squared to get to this? How many times does x squared go into 8x5? I guess that's a question. 8x3, exactly, right. And then you have to multiply 8x3 to all this, which comes 8x5 plus 16x3. And then you got to subtract these. I know it's kind of a pain, but you have to subtract it and put in parentheses, so that way you guarantee that this minus is true to both this and this. You have to do that. Yeah, sometimes some students won't realize that that's also being subtracted, so it's actually negative 16x3 when it comes out. These should cancel. That was the whole point. Again, to cancel. If you want to bring down the 0x4, go ahead. And negative 16x cubed. And I'll bring this down to 2 plus 2x squared. You always want to bring one more term down because you might need it. Now, how many times?
What would you multiply x squared? That's what it comes down to. What would you multiply x squared to get to 0x4? Nothing, right? There's nothing you would do to it. So let's not worry about it. What would you multiply x squared to get negative 16x cubed? What times x squared gets you negative 16x cubed? Negative 16x. Good. Thank you, buddy.
Negative 16x. Let me switch colors just to make this work a little more exciting. A little more stimulating. So negative 16x cubed and minus 32x. Because you got to multiply negative 16x, all that junk. And bring down negative 3x. Those cancel. 2x squared plus 29x. Plus 2. And then lastly, what would you multiply x squared to get to 2x squared? 2? Mm-hmm. Yep. So it becomes 2x squared plus 4. Get 29x. And that's your remainder. Okay. Yeah. So the final answer is going to be this. So not terribly fun problems. Not a big fan of this process, just so you know, but it's all right. I won't give you one quite this crazy. It's a little crazy. And when you do this in calculus, you don't do one that's crazy either. This is Mrs. Fu just being a little bit cruel. Okay. So in essence, what you've done
a cost value change. You have this giant fraction here. This giant fraction and all this are actually the same thing. If I were to graph this in Desmos and graph this in Desmos, I would get the same thing.
I get the exact same thing. And the reason why we do this, so Tammy, I know you're asking why we're doing this, because the way this is written right now, over here.
Believe it or not, actually, would be much if you start doing some calculus, you have to do some calculus techniques for this expression here. It's actually easier to work on ones like this as opposed to this. It won't make sense now to not take calculus, but when you do, this would actually be an easier expression to work with.
If you want to test to see if you got this right, again, you could graph this in Desmos, or you could plug in a number. And now this is where I could look like a jackass, but I hope I got this. Let x equal a number, like 1. If x equals 1, what is the top going to become if I plug a 1 into the top? 2 minus 3 plus 8 plus 2. 9, I think. And the bottom's 3. We get 3. Okay, keep my fingers crossed. I hope this comes out as 3. Plug in here. 8 minus 16 plus 2. Okay, I feel a little good as a 27 up top. And down below, I know it's a 9. Okay, I'm feeling good. Negative 8. Oh, shit. God damn it. Okay. Sorry for this morning. Okay, well, something happened. I don't know what happened. Oh man.
Is there meant to be?
I don't know. Something went awry. Okay, I'm not gonna go back and redo the problem because that would suck. But the point being is that you go through the motions. It should be the same. What did I do wrong? No. Man. 27. 9, 12, 9. I wonder if it should have been negative 8. No, it's not negative. No. Negative 8. Yeah, I don't know what I did wrong, but anyhow, we're just gonna move on. All right, Example 4. This should be a little more, this should be quicker. I can factor out 5 from the, actually, heck, let's just factor out -5 from the top. And 5 from the bottom here. And those cancel. So really what you got is -x5. Now I'm going to do the division. You know what? I'm sure I guess a better way. I'm not going to do long division. I'm kind of sick of this long division business. Do you guys remember synthetic division? You guys remember, have you guys done synthetic division? Is that okay? That's what I'm going to do instead. I'm going to do that instead.
This is what I was saying.
Yeah, this is better. Dude, there's no way you guys are playing baseball in this.
Oh, is that? Okay, I think I got it out.
Okay.
Thank you so
All right, good luck. Yeah, it's got to be dangerous for the pitcher, though, right? Okay.
Guys, quiet, please. So here's what I did. The leading term, take the coefficient of the leading term, which is -1. And then any term gets skipped over, you got the zeros placeholders, no x4s, no x3s, no x2s, no x. So 0, 0, 0, 0. And the end of the constant is -1. You have the placeholders when a term gets skipped over along the way, from the leading term to the constant. And then whatever makes this 0, that's what you put on the opposite for synthetic division. Because the assumption is you're factoring out x plus 1. Division is actually a factoring situation, right? Like 10 divided by 2 is 5.
2 is a factor of 10, right? So even if it doesn't sound clear, 11 divided by 2, you're still pulling a 2 out, right? So that's exactly what's happening here. So I'll bring this down. Now here's the process in case you guys forgot. You bring down that number. You multiply the outside to that number. What's -1 times -1? And then you rinse and repeat. Add that, that's 1. Multiply, rinse and repeat. Just keep going. And there you go. So what do these numbers represent? These numbers represent the coefficients of your answer. So it'll be -x4 plus x cubed minus x squared plus x minus 1. That's what that would be. Yeah. And if I were to plug in 1 into the original, I would get -1. If I plug 1 into this, I do get -1. So at least I know that works. Okay. Yeah, so my suggestion is use synthetic division if you can. The only problem is that synthetic division only works. You may want to write this down so you guys are not confused. Synthetic division only works when the denominator is a linear expression. Wow, that's really come down. So yeah, that's should be flooded. Yeah, good. Oh, sure. Hold on. Better? Okay, good. Let's be about Zoom. I could do that easily. Okay, so we're good. Good, I like it. It's good. All right. Now, second page. Sure, no problem. No problem. Here we go.
Thank you.
Okay. All right. So synthetic division again, more of the same stuff. You can't do it for example 6. I don't know why That's there. So let's just cross off example 6. Yeah, can't do synthetic division there, so forget about for example 6. Let's do it for example 5. -2, and it's got to go in order, right? So 1, 5. Now, what comes after the 5? Good, 0, -1, and -2. And you just bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. And it's just going to be x cubed. It's always 1 degree less, just so you know, too. X cubed always 1 degree less than the numerator. So x cubed plus 3x squared and again, I will plug 1 in.
Just make sure I did it right. So good check. You plug 1 in. That's gonna be 6 minus 3, so that's 3 over 3, so that's 1. Okay, let's make sure I did this right. 1 plus 3 minus 6 plus 11 minus 24 over 3. So that's 4 -2 plus 11. Yeah, I feel good about this. I got it. Come on. Yeah. Yep. So that's a good check. Plug in a number either like 1. See what the original expression would be. Plug 1 into your answer. See what that would be. That's gonna be the same. Obviously, I messed with the first one. I'm not gonna go back and do it because I don't want to. God bless it, by the way. Or in Desmos, just graph this and graph this. They should be identical. All this is just a cosmetic change. That's all you're doing. Just a cosmetic change this. Just so it's something that you can work with when you get to calculus. Like some sort of expression to be easy to work with. That's why we're doing it.
So it's really just a lot of that's hence why I call it pre-calculus, right? Just getting you guys ready for that next level. All right, we're not gonna do 6. Let's do 7 as the last one. Now 7. The only problem is that we need x minus c or x plus c. The coefficient of 2 presents a problem. So it's solvable, but does present a problem. In order for synthetic division to work, you have to have plain old x minus a number, plain old x plus a number, not 2x minus 3. What you do is you force the issue by forcing a 2 out of there. You force the 2 out of there. So I'm getting kind of lazy because I don't want to rewrite the top, but you force that 2 out of there. When you force it out, you get that. So what you're going to do is you're going to do a synthetic division like this. And don't worry about that 2. We'll have to worry about that 2 later. We'll worry about that 2 in just a little bit. So you bring the 2 down, multiply, add, multiply, add, multiply, add, multiply, add. Oh, 24. I think I did that right. No, I did it wrong. I made a mistake, guys. You see the mistake I made? What's negative 26 plus 18? Yeah, so negative 12. Okay, now I feel much better. 0. So you have 2x squared. No, sorry, 2x cubed minus 6x squared plus 12x. However, we pull that 2 out, right? So you still have to divide by 2. That 2 didn't vanish mysteriously. We still have to divide it. And if you do that, then you get the right answer. X cubed minus 3x squared plus 6x minus 9. And again, I'm going to check, see if I did this right.
Split 1 for x. We let x equal 1. What do you get? You get 23 minus 9 minus 26 plus 12. Down below you get negative 1. That's 14. You get 0. Okay, get 0. If I put 1 here, I get 1 minus 3 plus 6. Let me guess the. Yeah, yes, this is my area. It's not what?
Well, 2x is 2 minus 6x 2 plus 5.
6.
Minus 18. Then a minus 8. On the right, the dark blue. Minus 18 and 7 minus 8. On the right, check. One right. Up. Up.
What?
Right.
Oh, here?
That one. Negative 18. That's negative 8.
Oh, you're right. You're right. You're right. Thanks.
So I copied it wrong. Okay. Whew. So this is why you check, guys. This is why you check your work. All right, now I feel a little better. Thank you, Landland. I much appreciate it. Okay.
Now I feel a little better. Yeah, things do cancel against 0. Yeah. So I mean, I just copied the problems in. It happens. Or copy my answer. Okay. All right. So
I guess we're all set. Jake, can you go outside, please? Yeah, no worries. So yeah, okay. So homework is right here. Just work on it. And that's that. So, and the answer is already posted too. Let's see if any problems seem unreasonable, because I don't want you guys to keep doing crazy stuff. So I'm gonna update the homework, guys. You could do 1 and 2 using synthetic. You can do synthetic for 1 and 2. Just do long division for 3 and 4. Okay, just 3 and 4 do long division. Feel free to do synthetic for next class Friday. I'm gonna post it down. All right.
and it's just gonna be on the same page.
Yeah, well, there's someone last week stuff. Yeah,
So problems.
3 problems. Yeah.